Hello everyone, welcome back to my YouTube channel, Physics Fundamental with Thomas Adeoye. I'm happy to have you here with me, and today we are going to be discussing a very interesting topic in physics: vectors and vector addition. Some physical quantities such as time, temperature, mass, and density, they can be completely described by a single number with a unit. In other words, you can say that they can be completely described in terms of their magnitude only. You don't need any of that thing, just the magnitude. Look, for instance, mass. Let's take mass as an example. So if you are asked to weigh the mass of your food, your plate of food, if you place it on a weighing balance, it can be found, if you are a foodie, someone who likes food like me, to be 1.2 kg. That's great. So now the mass of something can be found to be 1.2 kg, and that makes sense. I mean, that is just what we need to completely divine the mass of an object, the mass of your plate of food. So suppose when you measure it, it is 1.2 kg, and that is just enough. Okay, and this kind of quantities, I mean such physical quantities that can only be described in terms of their magnitude alone, they are called scalar quantities. We call them scalar quantities. Okay, so we have another kind of quantities in physics which cannot be completely described in terms of their magnitude only. They have direction associated with them. In other words, we can say that these quantities can only be completely described in terms of their magnitude and direction. So they have direction associated with them, and such quantities, they are called vector quantities. So we have vector quantities. Okay, we are getting there. I'll better explain the difference between them using this is scalar quantity and this is a vector quantity. Now, to better explain the difference between scalar quantity and vector quantities, I'm going to use distance, which is a scalar quantity, and displacement, which is a vector quantity. Okay, so, and I'll picture a scenario. Suppose I was here at this point initially, and let me draw this. This is north, and let us assume this is a swimming pool. Okay, and this should be east. Yes, it is. Now, if this is playing ground and this is a south, so if this is food canteen, yeah, food canteen, so shorten as FC now. So if this is okay, this should be west. Okay, and let us assume this is church. Okay, church. Okay, CH to indicate church. Now, if someone come to ask of me, and this was where I was before, okay, and someone now comes around to ask of me, okay, so suppose from here to here is just 1 kilometer. From here to here, I mean each of them, each of the routes is 1 kilometer long. Okay, so now, and this was where this was where I was at the center. So if someone comes looking for me, okay, and suppose I already left this place, and when I left, I journeyed 1 kilometer from where I was. Look at the language. I just traveled 1 kilometer from where I was. So, and you know that telling the person that is looking for me that, oh, this guy Thomas traveled 1 kilometer from this place will get him confusing, in the sense that 1 kilometer from this place, if I take this road, and if I journey west, then it will take me straight away to my church. Now, if I decided to journey south, then it will take me to the, not south, it will take me to the food canteen. Perhaps I'm hungry. If I decided to journey east, that would take me to the playing ground. If I had journeyed north, then I'll get to the I think this is school, no, swimming pool. Yes. Okay. Now, so if the response that they gave the person looking for me is that Thomas journeyed 1 kilometer from this place, the only thing that the person was given is just my scalar quantity. I mean, just a scalar quantity, which is the distance I traveled. Because scalar quantity requires just magnitude to describe it. So if they say he journeyed 1 kilometer from here, so that 1 kilometer is just the magnitude and the units, which is a scalar quantity. But the person will have trouble finding me because he will have to try at least 3 or 4 different routes before he would be able to locate me. But if someone actually saw me and knew the direction in which I journeyed, the person would just mention that, oh, Thomas journeyed 1 kilometer north. So if I truly traveled 1 kilometer north, you know that 1 kilometer north will land me to the swimming pool. Then the person looking for me will just have to, take this route and find me where I am. So what I'm trying to say, or to let us see, is that if someone mentions 1 kilometer north, 1 kilometer is a magnitude with the unit. Now the north there indicates my direction of journey, and by definition, displacement is the distance traveled, is a 1 kilometer covered. Do you understand? In a specific direction or in a specified direction. The direction has been specified. That okay, you journey 1 kilometer, but not just 1 kilometer, 1 kilometer north. The direction is associated, it is attached to it. So that is no longer a scalar quantity, that is a vector quantity. So now we can say that for displacement now, it will be said that I journeyed 1 kilometer north. So, and for distance, what will be said is just that, okay, he journeyed 1 kilometer. Okay, so if you are looking for someone, you tell them, please don't give me a scalar quantity, give me a vector quantity, because with vector, then direction is is attached, and there won't be a confusion. Okay, and moving on, another difference between a vector and a scalar quantity is in how we add them, how we sum them up together. Look, for instance, for vector quantity now, for a scalar quantity, so if you have mass m1 to be 2 kg, let's say, and you have m2 to be 3 kg. Okay, so if these two masses are placed on a weighing scale, so far the weighing scale is accurate, then you should get 5 kg. Or better still, let me say that if they ask you that what is the sum of these masses, like the sum of m1 and m2, it is just as simple as 2 plus 3. and you would get 5. But if you have force of let's say 2 Newton south, and you have a force of, let's say, 3 Newton north. Okay, so if they ask you that what is the sum of these two forces, or better still, we can say what is the resultant sum or the vector sum of these two forces, okay, and you are thinking it is 5. No, you are wrong. Okay, so this is actually not 5, because in addition of vector, in adding two vectors together, you have to take into consideration their direction. Okay, so unlike scalar quantity, mass is a scalar quantity. We don't care, it does not even have the direction, so you just add up. But vector quantity, force, is a vector quantity. So that's why a force of 2 Newton, the direction is attached south. Now a force of 3 Newton, they indicate the direction to be north. So now this involves, it requires special kind of expertise now to find the sum, to add these two forces together. You want me to tell you the answer now? No, I won't. We have not gotten there. So this will lead us to addition of vectors. Addition of vector. That's why in most textbooks you can't find scalar addition, because it's just simple arithmetic, 2 plus 3. But as for vector addition, then you have to consider the direction. So, and that is the beauty in it. Now let's move on to the next slide. Here we are going to talk about representing a vector. Okay, so a vector can be denoted using a single letter with an arrowhead. Okay, if you check the previous slide, when I wanted to write a force of like F1 of 2 Newton south, so this is how I wrote it. Now look at this. I denoted this vector using a single letter F, then with an arrow on top of it. So this indicates that this is a vector quantity. Another way to do it is, in some textbooks you find it this way. Instead of putting an arrow on top, they'll put you see it this way, like a bar, not a bar, like a dash under, like this, beneath the letter. But I prefer representing my vector this way, and for the sake of my class, this is how I'm going to be representing a vector quantity. So you can denote it using a single letter with an arrow on top. Okay, for a scalar quantity, it is not so. When I wanted to write mass the other time, I just write single M with no arrow on top, because mass is a scalar quantity. Okay, and another way to represent vector is we can represent a vector quantity with a straight line with an arrowhead. Okay, so this is what I'm saying. You the other time, okay, let us assume this force of 2 Newton south can be represented like this. You just draw a straight line. So the length of this line indicates the magnitude, which is 2 Newton. Okay, and with an arrowhead, there has to be an arrow on its head. And look at where the arrow is facing. It is not, I didn't just draw it anyhow. It is because this guy is the vector, the force now is acting southward. So you can see on a cardinal point, then this guy is facing south. If I had drawn it this way, if the arrow is facing up, then this is not south, this is north. Okay, and the other time we checked the previous slides, I drew two vectors, two forces. Now one 2 Newton south, the other 3 Newton north. Then we can actually take this as that one of 3 Newton but north. And look at the difference now. I'll tell you the difference. The first difference is that the arrow, this one is facing down, which is south. This guy is facing up. The arrowhead indicates the direction of the vector. Now the length, how long it is, indicate the magnitude. This is shorter because the length of this is shorter because the magnitude is 2. Now the magnitude of this guy is 3. That's why it's longer. So these are the ways to represent a vector quantity. Okay, and we are going to discuss about the types of vectors. Okay, I'll say we have one parallel vectors, two vectors. Let's say vector A and vector B. So they are said to be parallel if they are facing, if they are in the same, they act in the same direction. Suppose we have vector A and vector B. You can see in a single letter with an arrowhead. Now, if this is vector B, so these two vectors A and B, they are they are parallel vectors because they act in the same direction. And another beautiful thing about parallel vector is that one thing about them, about parallel vector, is that the angle between them is 0 degree. So it's just the angle is 0, the angle between this guy and this guy, because they are parallel. Another thing about parallel vector which I want you to note is that they are the sum. Yes, if you want to find the sum can be found by simple addition. What do I mean by that? The other time I mentioned to you that if they ask you to find the sum of a force of 2 Newton south and a force of 3 Newton north, the answer is not 5. Okay, I've not told you the answer. We will in this class. Okay, but for parallel vectors, suppose those two vectors are parallel. If it had been said that, suppose we have a force of 2 Newton south and you have a force of 2 Newton south and we have force of 3 Newton south again. Now these two vectors, these two forces, they act along the same direction, south. Because they act along the same direction, we say they are parallel. And because they are parallel, the sum is just 2 plus 3, which is 5 Newton south. You can see we consider the direction. We didn't just add them up. So if you have two vectors that are acting along the same direction, just like this guy, force of 2 Newton southward, 3 Newton southward, both of them will look like this. Let me try to sketch. Both of them will look like this. Okay, so they are both acting south. So, and one of them will be longer because of the magnitude. So this guy, the sum will just be 2 plus 3. So now another beautiful thing about parallel vector is that to find their sum, you just, to find the resultant, you just take the sum and that shows it. But if they are not parallel, okay, that is, if they are not acting along the same direction, you can't just say you can't just add them up by taking the sum of their magnitudes. Okay, so another kind of vector we are going to look into, let's use the next slide, is equal vectors. So we have equal vectors. Okay, so for equal vectors, two vectors are said to be equal if they have the same magnitudes, but not just magnitudes, and direction. Okay, what do I mean? If we have vector A and let's use C, let's leave A alone. Let's use C. If we have vector C, for instance, and if it is 3 Newton let's use a displacement too, not just force. Okay, displacement is also a vector quantity. So if you have C, if this is 3 meter, let's say south, okay, and you have another force, and that one is also 3 meters south. Now this guy, these vectors C and D, they are equal vector because the magnitude is the same. 2, they have the same direction. Okay, now the next thing is negative of a vector. Another type of vector is negative of a vector. Okay, so which is number 3, negative of a vector. If vector A is like this, now the negative of vector A will be minus A. So minus A will be a vector which is of the same length as this guy but in opposite direction. This guy is facing east, while this is facing what? West. So that's opposite of a, like negative rather, of a vector. And the last kind of vector we are going to talk about is parallel vector. Sorry, we have talked about parallel vector. Now we talk about anti-parallel vectors. Okay, so two vectors are said to be anti-parallel when they are oppositely directed. You know, for parallel vectors, they are facing the same direction. And anti now, parallel vector, it means they are, if one is facing here, the other is facing here. So in other words, you can say that these two vectors, like vector A and it's negative, they are oppositely directed, then they are anti-parallel. Is that taken? So when vectors are facing opposite direction, when they are oppositely directed to each other, then we say they are anti-parallel. Now let's move on from the kinds of vector to vector addition and subtraction. Okay, in the real sense, there is nothing like vector subtraction actually. Okay, because if we have to subtract two vectors, is also almost the same as trying to find the sum of a positive vector and a negative vector. Anyways, we are going to get into that. So this is where the real thing is, in the sense that we want to do vector addition. Okay, and I've told you the reason why there is a need for us to do vector addition. It is because adding two or more vectors together requires expertise. You don't just take the magnitude and add them up. You have to consider the direction, and that's why we are doing this. That's why it's very, very important. And as a first year college student, you most likely be tested on your knowledge of vector addition. Okay, so now by definition, the vector sum or resultant C of a displacement A and B, displacement is a vector quantity, and this is a letter with an arrowhead. I've told you how to denote it. Okay, so C equals to A plus B. This is the mathematical representation, I'll say. So if they ask you to find the sum, or in other words, resultant of vectors A and B, you say that C is equal to A plus B. Okay, now for vector subtraction, this is how to write it. If they ask you to find you want to do this, A minus B. A minus B is same thing as saying A plus open bracket minus B. Okay, and you can see that we have not done anything wrong, in the sense that plus and minus will also give us minus. Okay, so we should move to the in the next slide. I'll show to you how to do some things. which is ways of adding factors. Okay, so we have different ways of adding factors. The first way is we can add factors by placing them head to tail. Okay, and we can also add them in reverse order given the same results, and also by placing them tail to tail and constructing a parallelogram. But the good news is that different methods of vector addition give the same vector results. Okay, even though you are using different method, you are still going to get the same result. Okay, now let me show to you some of the practical way to do this. The first one, which is head to tail. So for head to tail, suppose you have vector A and the vector is like this. It is acting this way, and you have vector B, and let us assume vector B is acting this way. Okay, so if you want to find the sum of the resultant, let's call the resultant C to be A. It's going to be A plus B now. Okay, so now the sum of this guy, if you want to use the first method, which is method 1, head to tail, head to tail. So head to tail means that you are going to place the head of any of the vectors. You can use any. So you are going to place the head of one vector. Now you place it with the tail of the other vector. Okay, so let's try by using, let's use vector A. So we are going to place the tail of vector B on the head of vector A. So that's what head to tail means. And if you do that, you will see that this is vector A. Okay, and vector B, you can imagine that you are carrying it, you take it and place the tail here. So this is A and this is B. Okay, so now if we are using head to tail, then the resultant, which is the sum, will now be measured from the tail of the one that is at the back to the head of the one that is in the front. So this will now be this line that is drawn. Oh, sorry, the line is not a good one. So this line that is drawn represents the resultant. So this is our A plus. This is just A plus B. Okay. So this diagram is very important. And when we get that to recalculation, you are going to see how it is that this is actually a very important thing to consider. Okay, now another method is by using tail to tail. Now we have used head to tail, so we place the head of one with the tail of the other, and the resultant is drawn from the tail of the one that is at the back. Okay, now to the head of the one that is at the front. Now the next thing is to use tail to tail. For tail to tail method means that we are going to place the tail of one to the tail of the other. So the tail of this with the tail of this, and that will be something like this. So this is vector B and this is its tail. Then we'll place it, and this is vector A. This is vector A and this is vector B. Don't mind it's not drawn to scale. Okay, so the tail of this with the tail of this. Let me try. This is longer. It's not as long as this. Okay, so we place the tail of this with the tail of this. Okay, now for the first method, which is head to tail, the resultant is the vector from the tail of the second vector to the, like a line that is drawn from this tail to this head is the resultant. But as for tail to tail, the resultant will be drawn from the point of intersection. I mean, where the tail and the tail, and the two tails, where they meet. So it's a line that is drawn from the point of intersection. Oh, how do I draw this? No, this is not a good line. Oh no. Coming. Okay. So it's a line that is drawn here. Okay. It's not that perfect, but this is what it means. Then this looks like this line is also the one that is here, and this one is also what we have here, and this makes a parallelogram with this guy as the resultant now, as the, what should I call it, as the diagonal. Okay, and here we have our C, which is A plus B. Okay, and mind you, whichever method that you can see that this line and this line, they look alike. In fact, they are supposed to be the same. If it is well drawn, they are parallel and the length should be the same. So this is to show that whichever method that you use, you are still going to get the same thing. Okay, so this will bring us to the end of today's class. So watch out for the next video, where we are going to delve into the pool of calculations on vector addition. This is to just solidify our knowledge or the foundation of vectors. Now that we know what vector is, you know the difference between scalar and vector quantities, and how it is that in vector quantity direction is very, very important, and the direction is also useful in doing the calculation. Now you must have understood how to denote vector, so that when you come around a letter with an arrow on its head, you know this is a vector quantity, and you know that before you can begin to add vector quantities together, you have to consider the direction of motion. Just like I've said, we meet in the next class. Thank you for listening. Do not forget to like, share, and subscribe. If you have any question or any comment, you can drop it in the comment section. I look forward to receiving a feedback from you. Thank you once